types of chemical equations that I want to teach you how to identify, and this is video number 50. Summary at the beginning. There are 5 types I'm going to teach you: synthesis, decomp, single replacement, double replacement, and oxidation. I'm going to want you to create a sentence for each type and describe how to identify it and what makes it unique. So here are those 5 reactions that I'm going to teach you how to classify. Synthesis. Synthesis means to put together, to make something bigger. It also means that your product is going to be bigger than your reactants. A very easy way to tell a synthesis reaction is there is only one plus sign and it is on the left. So here are a couple examples. So if you want like a formula, the top one's for you. So A plus B yields AB. You get an actual example down here. Hydrogen gas and oxygen gas yields water. And remember, synthesis is bigger and more complex with a plus sign only to the left. So a decomposition reaction, or decomp as I like to say it, means to break it apart. I like to say it means to bust it up. You are going into smaller pieces. Another way to say that is simpler pieces. The way to distinguish it, you're going to have a plus sign only on the right, and it's definitely less complex. So if you want a formula, you're going to start with AB, which is going to yield or bust up A plus B. We can then reverse the reaction that we just saw with water busting down into its parts, which is hydrogen gas and oxygen gas. And remember, this is the plus sign on the right only. So single replacement, what a replacement means is to trade places or swap. In a single replacement, only one element replaces another one. You look for the single element all alone. I call it the table for one element. And the way to identify this is you're going to have a plus sign on both sides. So here's what it looks like. A plus BC yields, remember you're swapping it around, B plus AC. And here's another one for you here. You've got potassium and water, which is getting rearranged into hydrogen gas and potassium oxide. Remember, look for that element that's all alone and make sure you have a plus sign on both sides of the equation. So double replacement's similar to a single, except 2 elements replace each other. Basically, everybody has a date, or everybody decides to swap dates. You're going to notice a plus sign on both sides, but there will be no single elements. You're going to have compounds all around. So take a look at this. You've got AB plus CD. Everybody rearranges, decides they like somebody else, and you've got AD plus CB. Same thing down here with iron and sulfur plus your hydrochloric gas. Everybody switches around. So everybody has a date, plus sign on both sides.
Reaction with potassium chromate and silver nitrate. Here's my potassium chromate, and I see that when I add silver nitrate to it, I am forming a nice red precipitate.
So oxidation reactions are special. This is when metals react with oxygen. It's a very special kind of synthesis reaction. You look for the oxygen alone. That's always a great way to be able to tell. Plus you always see a plus sign on the left. I'm showing you what happens when metals react with oxygen and you get all that rust. So oxidation is a metal plus an oxygen, gives you a metal plus an oxygen together. I've got you calcium and oxygen here. It's a very special case. It's a synthesis reaction which has oxygen all alone. I'd like you to put me on pause, write down these 5 equations, and let's see what you can do with them. Can you classify them? Okay, how'd you do? Did you see the plus sign for number 1 on the left alone? That's a synthesis. Number 2 is the complete opposite of that with the plus sign on the right as a decomp. Number 3 is my table for 1. Did you notice my zinc is all alone and then my hydrogen's all alone, but there's plus signs? That's single replacement. Oxidation, remember synthesis with an iron, right? I mean a metal. Iron is a metal. And then number 5, a double replacement. Notice the plus sign on both sides, but everybody has a date. There are 5 types of reactions. Create a sentence for each, and then tell me how you would identify it and what makes it unique. As always, thanks for watching, and if I don't tell you guys enough, you're always doing a great job. Thank you so much, and I'll see you in class.